Good morning, dear students. Welcome back to physics class. Today, I would like to present a new topic which is resolution of a vector in a plane. Before I going to take this topic, I introduce you a new part, collinear vectors. What are collinear vectors? Two vectors are said to be collinear vectors if they lie on the same line or parallel lines. As shown in given figure, two vectors which are vector A and vector B are collinear to each other. Here, these collinear vectors are co-directed as they have the same directions. Collinear vectors may not be always in same directions, they may be in opposite directions. You should note that one of two collinear vectors should be a scalar multiple of another. When you studied about the collinear vectors, it is essential to know about some basic of coplanar vectors. What are the coplanar vectors? Three or more vectors are said to be coplanar vectors if they lie in the same plane, which are shown in given figure. What are the important points regarding to coplanar vectors? Any two non-collinear vectors are called coplanar vectors, and if three non-collinear vectors are coplanar, any one of them can be expressed as a linear combination of other two. Now, let me discuss on the topic resolution of a vector in a plane. For ease understanding of this subject, it is important to know about the concept unit vector. What is a unit vector? A unit vector is a vector of unit magnitude and points in a particular direction. It has no dimension and unit. It is used to specify a direction only. These unit vectors are perpendicular to each other. They are printed in boldface with a cap, whose symbol is given in this slide to distinguish them from other vectors. Unit vectors along the x, y and z axis of a rectangular coordinate systems are denoted by I cap, j cap and k cap respectively, which are shown in given figure. So, the magnitude of unit vectors are given by mod or modulus of I cap is equal to modulus of j cap is equal to modulus of k cap, which is also equal to 1. If you multiply a unit vector, say n cap, by a scalar quantity, the result that you will get will be a vector quantity. This is represented by vector lambda, which is equal to lambda n cap, where lambda be the magnitude of the vector lambda and n cap be the unit vector along the direction of the vector lambda. In general, a vector A can be written as vector A is equal to modulus of vector A into n cap, where n is a unit vector along the vector A. The vector A is also can be expressed as vector A is equal to A n cap, where A be the magnitude of the vector A. Now, let you think about how can be vectors resolved. Can you say what is the resolving process? Resolving process means that splitting of something into number of its component forms. A vector can be expressed in terms of other vectors in the same plane. How can give the clarity to this subject? Suppose there are three vectors. The first vector can be expressed as sum of second vector and third vector after multiplying them with some real numbers. Let vector A and vector B be any two non-zero vectors in a plane with different directions, and let vector A be another vector in the same plane as shown in given figure. Then vector A can be expressed as sum of two vectors. First vector is obtained by multiplying the vector A by a real number lambda, and second one is obtained by multiplying the vector B by another real number nu. To see this, let the point O and the point P be the tail and head of the vector A. Then, through the point O, draw a straight line parallel to the vector A, and through the point P, a straight line parallel to the vector B. Let these two lines intersect at the common point Q. Then we can write as vector A is equal to vector OP, which is equal to vector OQ plus vector QP, where vector OQ is equal to lambda vector A and vector QP is equal to nu vector B. So, we have written as vector OQ is equal to lambda vector A and vector QP is equal to nu vector B, as vector OQ is parallel to vector A and vector QP is parallel to vector B, where lambda and nu are the real numbers. So, it can be mathematically expressed as vector A is equal to lambda vector A plus nu vector B, which is the expression 1. From the expression 1, it means that vector A is resolved into two component vectors, which are lambda vector A and nu vector B, which are along the directions of vector A and vector B respectively. Using this method, one can resolve a given vector into number of its component forms along a set of two vectors. Here, all the three vectors lie in the same plane, which is shown in given figure. Can be it possible to resolve a general vector along the axis of a rectangular coordinate system using unit vectors? Yes, it is convenient to resolve a general vector along the axis of a rectangular coordinate system using these unit vectors. So, we can resolve a vector A in terms of component vectors that lie along unit vectors I cap and j cap. You have to note that any two unit vectors here, the unit vectors I cap and j cap, are used to resolve the given vector, because our chapter is about two-dimensional motion or motion in plane. Consider a vector A that lies in xy plane as shown in given figure. At first, you have to draw the lines from the head of the vector A perpendicular to the coordinate axis as shown in figure 1 and get the vectors which are vector A1 and vector A2 such that vector A1 plus vector A2 is equal to vector A. Since vector A1 is parallel to the unit vector I cap and vector A2 is parallel to the unit vector j cap, then we have vector A1 is equal to Ax I cap and vector A2 is equal to Ay j cap, which are represented in figure 2, where Ax and Ay be the real numbers. So, the vector A can be mathematically expressed as vector A is equal to Ax I cap plus Ay j cap, which is the expression 3, which is also shown in figure 2. You should see that the quantities Ax and Ay are called x and y components of the vector A. You have to note that Ax is itself not a vector, but Ax unit vector I cap is a vector. Similarly, Ay is itself not a vector, it is just only the magnitude of the vector Ay j cap. Then, by applying the trigonometry, the functions used here are sine and cos. Tan you studied earlier. What are the sine and cosine function? From a right triangle, sine theta is equal to the opposite side of the right triangle divided by its hypotenuse, and cos theta is equal to its adjacent side divided by its hypotenuse. So, we can express the magnitudes Ax and Ay of the vectors Ax I cap and Ay j cap respectively in terms of the magnitude of vector A and the angle theta it makes with the x-axis. From the given figure below, theta be the angle made by the direction of the vector A with respect to the x-axis. Then cos theta is equal to adjacent side divided by hypotenuse of the given right triangle. Adjacent side is represented by Ax and hypotenuse is represented by A. Then cos theta is equal to Ax divided by A. Then Ax is equal to A cos theta, which is the expression 3. And what should be the sin theta? Sin theta is equal to opposite side divided by hypotenuse. Here the opposite side is Ay and hypotenuse is A. So sin theta is equal to Ay divided by A. Then Ay is equal to A sin theta, which is the expression 4. So, we have the expressions which are Ax is equal to A cos theta and Ay is equal to A sin theta. From these expressions, it is understandable that a component of a vector may be positive, negative or 0 depending on direction of the vector A with respect to the x-axis or the value of angle theta. Then you should answer this question: what are the two ways to specify a vector A in a plane? They are: first one, which can be expressed in form of its magnitude A and the direction theta it makes with the x-axis. That is, vector A is equal to mod or modulus of vector A into the unit vector n cap or A n cap, where n cap be the unit vector which specifies the direction of the vector A or the angle theta with respect to the x-axis. N cap may be I cap or J cap or K cap. And second one, which can be expressed in the form of its components Ax and Ay. That is, vector A is equal to Ax I cap plus Ay J cap. How can you find the values of Ax and Ay if the magnitude of the vector A and theta are given? You should use the expressions 3 and 4. And how can you find the values of the magnitude of the vector A and theta if Ax and Ay are given? First, you have to square the expressions 3 and 4. You get A square is equal to A square cos square theta, which is the expression 5, and Ay square is equal to A square sin square theta, which is the expression 6. And then you have to add the expressions 5 and 6. You get A square plus Ay square is equal to A square cos square theta plus A square sin square theta. Since sin square theta plus cos square theta is equal to 1, then this expression will become as A square plus Ay square is equal to A square. Then A is equal to square root of A square plus Ay square, which is the expression 7. You got the magnitude of the vector A. Then how can find the angle theta? For this, you have to divide the expression 4 by the expression 3. You get Ay by Ax is equal to sin theta by cos theta, which is equal to tan theta. Then tan theta is equal to Ay by Ax. So theta is equal to tan inverse Ay by Ax, which is the expression 8. So far, we have considered a vector lying in an xy plane. The same procedure is useful to resolve a general vector A, which is positioned in space into 3 components along x, y, and z axes in 3 dimensions. If alpha, beta, and gamma are the angles between the direction of the vector A and the x, y, and z axes respectively, which is shown in given figure. We have Ax is equal to A cos alpha, Ay is equal to A cos beta, and Az is equal to A cos gamma. In general, we have vector A is equal to Ax I cap plus Ay j cap plus Az k cap. Then the magnitude of the vector A can be mathematically expressed as square root of A square plus Ay square plus Az square. Then how can we express the position vector R? The position vector R can be expressed as position vector R is equal to x I cap plus y j cap plus z k cap, where x, y, and z are the components of the position vector R along x, y, and z axes respectively. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.